Hi everyone, so now we're going to learn how to solve systems of equations with elimination. We've already learned how to do it with a table and then with graphing and with substitution. This is the last way we can solve systems of equations and elimination. And this one, with elimination, it's easiest to use elimination when you have your x's and y's all lined up. And usually we put them into something called standard form. You guys haven't learned about that quite yet, but standard form is when you have the x's and y's on the left side and then just numbers or constants on the right side of the equal sign. So there's a couple of different options for this elimination, but let's get started with one of the easiest, which is the first example. So when we do elimination, what we're going to do is actually have them lined up like we talked about, and then just add the equations together. So add the x's together, add the y's together, add the things without the x's or y's together, and see what we come up with. So on this one, and the way that I like to do is I like to draw a line below it just to kind of show, okay, we're going to add these together. So for the x's, I have a positive x and a negative x, or a 1x and a negative 1x. Well, 1 minus 1 gives me 0, right? So what that tells me is that the x's actually cancel each other out, because a positive x and a negative x would give me 0. So I can write 0, or I can just cross them out. Then for our y's, we have negative y and negative 2y. That's like a negative 1y. So negative 1y and negative 2y would give me a negative 3y when I add them together. And then on the right-hand side of the equal sign, we have a negative 6 and a negative 15, which gives me negative 21 when I add those together. So now we just have this equation, and if we scratch out the 0, we have this equation that says negative 3y is equal to negative 21. We have one equation with one variable, which means we can solve for that one variable. To solve for y in this case, we're going to divide each side by negative 3. So divide by negative 3, divide by negative 3. The negative 3 is on the left side, cancel out, we're just left with y. Then on the right side, we've got negative 21 divided by negative 3, which gives me 7. So now I know that y is equal to 7. Hooray! But as you well know, that is not my full answer. I still have to have an x equals. So to get the x equals, what I'm going to do is just go back to one of my original equations, and it doesn't matter which one, so I'll just choose the x minus y is equal to negative 6. And what I'm going to do is replace the y, or the thing that I know, with my answer. So what I'm going to do is rewrite x minus, but instead of saying y, I'm going to say 7, because I know that y is equal to 7 now, equals negative 6. And I can solve this equation for x, because now I only have one variable, and that variable is x. So to solve this, what I'm going to do is add 7 to both sides. The 7's cancel out right here, and I'm just left with x on this side. And then negative 6 plus 7 gives me 1. So now I have x equals 1. So because I have an x equals answer and a y equals answer now, my final answer is x is equal to 1 and y is equal to 7. All right. So for the next example, sometimes, well, let me backtrack and say this. For the first example, the x's just automatically canceled out. We just added them together, the x's canceled out. But sometimes you can't get them to just automatically cancel out. You have to multiply by something. So for the second example, if you look at your y's, you have an 8y and an 8y, which is great. Like if one was positive and one was negative, we could just add them together. But unfortunately, they're both positive. So what I'm going to do is I'm going to take the second equation. It doesn't really matter if I took the first or the second, but I'm going to take the second equation and multiply it by negative 1. When I multiply it by negative 1, all that happens is all the signs flip-flop. So I'm just going to rewrite the top equation. It's because I didn't multiply it by anything. And the bottom equation, I'm going to multiply everything. I have to multiply everything in order for it to work. If you only multiply the thing you want to cancel out, it doesn't actually, it won't be helpful. You have to multiply everything in that equation. So I'm going to do 4x times negative 1, which gives me negative 4x. 8y times negative 1, which gives me negative 8y. And then 20 times negative 1, which gives me negative 20. Now I should be able to add these together and the y's will cancel out. So let's start with the x's though, because they come first. We have negative 10x and negative 4x, which would give me negative 14x. Then we have the y's, which are positive 8y and negative 8y. That's great. They cancel out because positive and negative, the same number, cancel out. And then on the other side of the equal sign, we have 6 and negative 20, which gives me negative 14. Now I have one equation with one variable, so I can solve that equation by dividing each side by negative 14 to get the x by itself. The 14s cancel out over here. We're just left with x. And then on this side, we have negative 14 divided by negative 14, which gives me 1. So now I know x is equal to 1. That's great. What we're going to do now is actually solve for y, right? Because we only have half of our answer. To find the other half of the answer, we have to take one of our original equations. It doesn't matter which one, whatever one you think is easiest. So I'm just going to take the top one and replace the x with what I already know. So I know x is equal to 1, so I'm going to say negative 10 times, instead of x, 1 plus 8y is equal to 6. Well, negative 10 times 1 is just negative 10, so it's negative 10 plus 8y is equal to 6. Then I'm going to add 10 to each side, or now I'm going to solve for y because that's the only variable left. So I'm going to add 10 to each side to start that process. The 10s cancel out over here, and we're just left with 8y, and then 6 plus 10 on the right side gives me 16. Then to get rid of the 8, we're going to divide each side by 8. The 8s cancel out over here. I'm just left with y, and 16 divided by 8 gives me 2. So I know that y is equal to 2, which means my full answer is x is equal to 1, and y is equal to 2. Perfect. All right, let's do another one. So that time we had to multiply by negative 1 in order for it to work. This time we're going to have to multiply by a number, or like a bigger number. So when I look at these, I'm trying to find something that's like a multiple of 2 or a multiple of 3, something that is a little bit easier to work out. So if you look at the x's, you have a negative 18x and a positive 9x. Well, if I multiply this whole bottom equation by 2, then the 9x will turn into a positive 18x, which will cancel out with the negative 18x on the top. So that's exactly what I'm going to do. I'm just going to rewrite the top equation though first. And then on the bottom equation, we're multiplying everything by 2. Remember, you have to multiply everything in the equation. So 9x times 2 gives me an 18x. Negative 4y times 2 gives me a negative 8y. And then a negative 23 times 2 gives me a negative 46. All right. So now we're going to add those together. We have a positive 18x and a negative 18x, which cancel each other out. That's great. Then for the y's, I have 10y minus 8y, which gives me 2y. And then on the right side of the equal sign, we have 26 minus 46, which gives me negative 20. Now we can solve that equation for y because y is the only variable left. And to do that, we're going to divide each side by 2. The 2's cancel out on the left side. We're just left with y. And then on the right side, I've got negative 20 divided by 2, which gives me negative 10. So I know that y is equal to negative 10. To solve for x, remember, because we need x, we're going to take one of the equations. This time, let's use the bottom one. So 9x minus 4y is equal to negative 23. I used the original equation, but potentially could use the equation multiplied by 2. Doesn't really matter. And I'm going to replace the y with negative 10. So I'm going to say 9x minus 4, but instead of y, I'm going to say negative 10 equals negative 23. Then I'm going to simplify by multiplying the negative 4 and the negative 10. So I get 9x. Negative 4 times negative 10 is a positive 40 because the negatives cancel out. Now I'm going to solve that for x. The first step I'm going to take is by subtracting 40 from each side. So I get 9x, because the 40's cancel out, is equal to negative 63, because negative 23 minus 40 is negative 63. And then we're going to divide each side by 9. The 9's cancel out on the left side. We're just left with x. And then on the right side, I've got negative 63 divided by 9, which gives me negative 7. My final answer is x is equal to negative 7 and y is equal to negative 10. All right. Let's do one more example. And on this example, once again, we're going to try and find a chunk that's like we can multiply by 2 or 3. The y's have a 9 and a 2. 9 and 2, you would have to multiply, like there's nothing that makes a 2 a 9 that's a whole number, but the 4 and the 12, I can multiply the top equation by 3 and make it a 12. Now, I don't want to multiply it by just 3. I want to multiply it by negative 3. And the reason why I want to multiply it by negative 3 is because I want those numbers to have opposite signs, right? The bottom equation has a positive 12x, so I want my top equation to have a negative 12x so they cancel out. So when I rewrite that top equation, I'm going to multiply everything by negative 3, and 4x times negative 3 gives me a negative 12x. Then negative 3 times 9y gives me a negative 27y. And then 15 times negative 3 gives me negative 45. Then let's just rewrite the bottom equation because we didn't do anything to that one. Then we're going to add them together. So we have a negative 12x, positive 12x. They cancel out, which is what we want. Then for the y's, we have negative 27y and a positive 2y, which gives me negative 25y. And then negative 45, negative 30 gives me negative 75. So to solve this for y, I would divide each side by negative 25. The 25's cancel out on the left side, we're left with y. Negative 75 divided by negative 25 gives me 3, so I know y is equal to 3. That's not our full answer. We have to solve for x. To solve for x, I'm going to take one of my top equations. I'm going to use the bottom one again, so 12x plus 2y is equal to negative 30. But now that I know y is equal to 3, I'm going to replace the y with 3. And then solve. So to solve, I'm going to multiply the 2 and the 3, which gives me 6. Then subtract 6 from each side. The 6's cancel out over here, so I'm just left with 12x. Negative 30 and negative 6 give me negative 36. And then we still want to get rid of the 12, so to get rid of the 12, we divide by 12 on each side. The 12's cancel out on the left side. We're just left with x over here. And then negative 36 divided by 12 gives me a negative 3, which means that x is equal to negative 3 when y is equal to positive 3. That is my full solution. And there we have it, how to solve systems of equations with elimination.